transverse direction. So this is in a transverse direction. If the pressure intensity between 11.4 and 14.9 of the wind pressure doesn't change significantly, the total force will be acting at the centroid of this area. This total force is then to be distributed to the distribution joints where you have the columns. We are assuming that these are distributed equally by dividing it by the number of joints. So we have done that in our calculation. We obtain the total force in each wing. So if you look at let's look at this thing very carefully. So the structure has two wings. This is one wing and that's another wing there. So we calculated the total force in one wing. Whatever we calculate on these joints is what we're going to also apply on the other joint because of symmetry. Okay, if the wing is different, if the configuration here is different, the total force times this area will give the total pressure times this area will give a total force, and then you then calculate the corresponding wind forces on the distributed joints. If there are openings on the structure, then this total force is reduced by what we refer to as the exposure area. The ratio of the opening to the total, the ratio of the area of the opening to the total area of the applied wind pressure. So now we calculate the wind force at that elevation. Let's start with the roof level. Okay, the total wind force, look at that. This is the area. Total wind force we calculated is 45.7 kilonewton at the roof level, and it's acting here. But the total force per joint divided by 8 is 5.7126. This in the transverse direction. So we add in the Z direction joint load in the Z direction. So you see 5.7126. Add. So we're going to rotate the structure. We're going to apply it on, in order not to make a mistake, I want to select this entire plane. So I go to left view and then select this plane. Okay, so if you rotate this, you can see very carefully now your roof level. Check the coordinates. This is 14.9. Yes, you are correct. So we are going to apply it on these tributary joints. Here, here. Great, because that's a closed area, right? In the same vein, so these are this elevation. Let's look at what's happening on this other lower elevation in the Z direction. Let's go to, okay, so this is on the first floor level. Let's look at the second head good. So second and third floor, what is the wind load? On the second and third floor, we're having the wind force to be approximately the same 5.2896. So it's slightly lesser than what you have on the third and fourth floor, because of you realize that the wind pressure varies with height, with elevation, because of the velocity profile. So the velocity profiles is very important in determining the intensity of wind pressures in several elevations. So as the velocity profile changes, as the elevation increases and you have lesser drag, you have increased wind pressures. So between the second and third floor, we had calculated the wind load in the z direction transverse to be 5.2896. So this is Z. So you apply it here. There was a mistake here. Let's create it again. So you assign select the correct nodes. You make sure you don't make mistake in your node selection process. Yeah, that's fine. Okay, so these are closed regions. So you then now apply the wind load from the ground floor. Okay, this elevation 4.4. So this same load is also the same pressure on the first floor elevation. So we apply it on the first floor joints as well because it's closed. So if you look here, this is the wind load on the second and third floor. So it's the same. So the same load you apply. So this is second and third floor. Okay. Second and third floor. So this is first, second, and third. So the load on the second and third floor, what we have applied. Now, if you look at the first floor, this is the first floor. Look, the first floor is suspended and it's opened. It's an open structure. So the wind loading on the first floor is going to be distributed load on the columns. It's not going to be joint loads like you have on this second and third. Here you're going to have distributed loads. Okay, together with joint loads which you're going to have, which are associated with the pressure between the first and second floor. So that joint load is what I'm going to apply here between the first and second floor, which is this. And then you see this is what we have. On the first floor, which is opened, let's look at what we calculated. First floor is an open structure. Okay, so first floor is an open structure. So the wind loading was calculated as a pressure load, which is going to be applied on the columns.